So we are starting trig, and we're going to do trig for the rest of the year. Today, we're going to spend some time reviewing what you learned back in geometry. I think for many of you, was geometry the class where COVID happened and then you were out for the last quarter of the year? Okay, so it'll be good for us to do a review. This part, if you don't want to write this down, fine. If you want to squeeze it into the margin or something, that's fine. I'm going to take a picture of it and post it on Schoology, but I just want to review triangles real quick, all right? Does anyone remember what the triangle angles add up to? Good. Oh, and while I'm thinking about this, you need to be in degree mode for this, or literally all your answers will be wrong. So everyone take your calculator, go to mode. It's right here next to second. And the default is radians. I'm going to teach you radians, and we're going to do radians later this year, but for right now, we're in degrees. The default is radians though, so you need to go down and change it to degrees, or literally everything will be wrong. So please go change it to degrees. All right, so angles add up to 180 in a triangle. An equilateral triangle. Again, I'm going to take a picture of this and post this. You know, like if you just are paying attention, that's good. An equilateral triangle. What does that mean if your triangle is equilateral? And if all three sides are the same, what else? All the angles are the same. So all sides and angles are the same. So if I draw a picture of an equilateral triangle, all the sides are the same. And what does that mean all the angles are? It means all the angles are 60 degrees. It's 180 divided equally, they would all be 60. All right, the other word we're going to need to remember is isosceles. An isosceles triangle. I will tell you if you've all forgotten. Does anyone remember what an isosceles triangle is? Two of the sides are the same. Good. So two sides and angles are the same. And so that would look like this. These two sides would be the same, and then the angles across from them would be the same. So basically like some symmetry there. All right, and the other thing I want to review real quick deals with square roots. You're going to do a lot with square roots with this topic. So let's review how to split them. For example, if you have a square root of 20, how will that split up? I need two numbers that multiply together to be 20. 4 and 5, and the whole point of choosing 4 is square root of 4 is 2. So 2 square root of 5. Does that ring any bells? I'll make up another one if you want me to. Let's do square root of 75. What would that split into? Good. And then square root of 25 is 5. So 5 square root of 3. You're going to have to be able to do that. Okay. You learned it in algebra 2. I'm just bringing it up again. And then the last thing is you're not allowed to have a root in the denominator. And I don't know whether they covered this for you in algebra 2 or not, but I'm just going to go over it real fast. Give me some numbers. Say you have 7 over square root of 3. You're not allowed to have a square root in the denominator. So here's how you get rid of it. You would multiply by square root of 3 in the numerator and the denominator. So in the numerator, you would just have 7 square root of 3. In the denominator, what is square root of 3 times square root of 3? Be square root of 9, which is 3. And then you don't have a root in the denominator anymore. Yes. It will always cancel out. And so what I want you to eventually get to the point is where you don't have to write this. Let me make up another one. Say you have 4 over square root of 5. If you multiply by square root of 5, you would get 4 square root of 5 over 5. Okay, that's called rationalizing. You're not allowed to have a root in the denominator. Okay, so I just wanted to review those couple of things before we start. Again, I'm going to take a picture of this and put it on Schoology. Pythagorean theorem. Does anyone know it? I will tell you if you've forgotten. Good. A squared plus b squared equals c squared. Now, it is specifically only for right triangles. It will not work unless it is a right triangle. And it doesn't matter where you put A and B, but C has to be the hypotenuse. What is a hypotenuse? Because it's a strange word. Yeah, good. It's across from the right, the biggest side. All right. So it doesn't matter. Like I could have put A here and B here, but C has to be the hypotenuse. Now there are what are called Pythagorean triples, which are values that work out to follow this, and they're whole numbers. I call them the locker combination ones because that's what they sound like. 3, 4, 5. If you know nothing else, you want to know 3, 4, 5. 3 squared plus 4 squared equals 5 squared. But here's a couple others. 5, 12, 13. 7, 24, 25. And 8, 15, 17. I can't crawl in your brain, make you memorize them. I'm just going to throw it out there as a suggestion. And there are more. Those are the ones I have memorized. If you kind of just know those, they'll make your life easier when you get to problems that involve them. And if nothing else, can you just know 3, 4, 5 for me? Like, I don't think I'm asking too much with that one, right? So find the missing side for each triangle. You can call this either A or B. You can call it X or Q. I don't care what you call it. I'm going to call it A. This would be A squared plus 4 squared equals 10 squared. Make your geometry teacher proud. So that would be A squared plus 16 equals 100. Subtract over the 16, we would have A squared equals 'You all forgot you have a calculator? 84? And then we're going to square root. Now you need to split up 84. What are we going to split 84 into? And you can use your calculator to try some stuff. One of them needs to be a perfect square. Yes, ma'am. 4 and 21. And so it would be 2 square root of 21 is your final answer for that side. Do you remember that sort of from 2 years ago? Vaguely. All right, let's set up this one. A squared plus 7 squared equals 15 squared. So that will be A squared plus 49 equals 225. Thank you. I don't have them all memorized. I do know 15 squared though. All right, 225 minus 49 gives me 176. And then square root, you're going to have to split that. So try in your calculator 176 divided by some of the perfect squares. I think 16 might be the 16. So 4 works, but you want the biggest one. 16 also works. So it'd be 16 and what? 11. Good. So it would be 4 square root of 11. And then for that last one, you can avoid doing any work at all because it is one of the locker combination ones. It's one of the triples. 5, 12, 13. And that's what I was saying is if you know those ones, it will make your life easier when you run a cross run of them. Now, if you worked out the problem, you would still get the answer, but I'm just trying to make life easier for you. All right, now we're going to do our special right triangle. This one is 45, 45, 90, which means it is isosceles. 2 of the sides and 2 of the angles are the same. So when you go to do Pythagorean theorem, instead of A, B, C, you have A, C. Do you see what I'm saying? Because 2 of them are the same. So if we go to do Pythagorean theorem for that, it'll be A squared plus A squared equals C squared. And what would A squared plus A squared give us? Yeah, good, 2 of them, 2A squared. And then you would square root both sides, and the squareds and the square roots cancel. So this would be square root of 2 times A equals C. So if you take the smaller side, multiply it by square root of 2, you're going to get the hypotenuse. Just take this, multiply it by square root of 2, you're going to get this. So if you want to go the other way, if you take C and divide by square root of 2, that's going to give you A. So you just either multiply or divide by square root of 2. Let me show you what I mean. We'll do a couple of problems down here. Do you see questions 4 and 5? Let's do those ones. Do you see how that's labeled as 45? Are y'all together here? So it is 45, 45, 90. So if this side is 18, this side is also 18. And then to get the hypotenuse, you would just multiply by square root of 2. So it would be 18 square root of 2. See, so we did that like with no work. So this one again, it's 45, 45, 90. Now this time the hypotenuse is 18. So to get from there to one of the smaller sides, you would divide by square root of 2. Now we're going to rationalize that. That would give us 18 square root of 2 over 2. And then 18 divided by 2 is 9. So this would be 9 square root of 2. And that means that the other side is also 9 square root of 2 because it's isosceles and they're the same. Did you get to that unit when you were all in geometry, or was that like after chaos erupted? Right when that happened? Okay. Okay. You've never seen a triangle. Okay, anyway, for the 45, 45, 90, you just multiply or divide by square root of 2. All right, here's the other special one, 30, 60, 90. Oops, not 36. 30, 60, 90. It's not isosceles. You have a small side, a big side, and a hypotenuse. The small side goes across from the 30, the big side goes across from the 60, and then the hypotenuse goes across from the right angle, okay? To show you where this pattern comes from, what we're gonna do is draw in like a symmetric triangle to cause this to be equilateral. We're gonna make it be 60, 60, 60. So for this, we have ABC, but watch me point to this. If this is C, and I just made this equilateral, this is also C, and that means this is also C. They're all C. Coming with me on that thought journey? So how would I get from A to C? A is how much of C? Half. Good. So 2A would give you C. Or if you want to go the other way, C divided by 2 will give you A. So to get from the hypotenuse to the smaller leg, you just multiply or divide by 2. Now we're going to have to work this out to get B in there. B is the kind of tricky part there. So it will be A squared plus B squared equals C squared. But instead of C, I'm going to put 2A. C is the same as 2A for this. So it's the Pythagorean theorem is just C equals 2A. Now we're going to square that part. What would that give us? 4A squared. And then we would want to get all the A's together. So if you subtract over an A squared, 4A squared minus A squared would give you 3A squared. And then you would square root. So B equals square root of 3 times A. And if you want to go back the other way, you would just divide by square root of 3. So to get from the small side to the bigger side, you multiply or divide by square root of 3. Oh, okay. So for these ones, you either multiply or divide by 2, or you multiply or divide by square root of 3. I just went through the explanation of why that is what it is. The problems aren't actually that hard, but what you have to remember is the triangles aren't drawn to scale, okay? So they don't look, like the angles aren't exactly correct for how they would look. So this says 60, across from 60, this is the big side. Across from the 30 would be the small side. So to get from here to here, we're gonna divide by square root of 3. So to get from the bigger side to the smaller side, divide by square root of 3. All right, when you rationalize that, what are you going to get? Good. And then 18 divided by 3 is 6. Good. So this will be 6 square root of 3. And then to get from the smaller side to the hypotenuse, you would multiply by 2. So if you take this and multiply by 2, it will be 12 square root of 3. All right, let's try this one. Again, the triangle is not to scale. You are given the hypotenuse. To get from the hypotenuse to the small side, you're going to divide by 2. So 18 divided by 2 gives you 9. So the side is 9. And then to get from the small side to the bigger side, you multiply by square root of 3. So it would just be 9 square root of 3. All right, and then last one of these. We have the small side. To get to the hypotenuse, you're going to multiply by 2. So what is the hypotenuse going to be? Good, that'll be 36. And to get from the smaller side to the bigger side, you multiply by square root of 3. So it would just be 18 square root of 3. Let me recap that. You're either multiplying or dividing by square root of 2, square root of 3, or 2. So like there's very limited options there, but those are your patterns. I'm going to just keep going so we can finish up because this isn't going to be too bad. All right, right triangle trig. Does anyone remember what the like little acronym is for this? If you remember nothing else from geometry, you probably remember this. SOHCAHTOA, do you remember that? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You need to make sure you are in degree mode, and your opposite and adjacent are different depending on where your point of view is. Humor me and let me explain this to you, okay? If here's your right triangle, no matter what, this is the hypotenuse. Like that's going to be the hypotenuse. If this is the angle that's labeled, and we use theta for our angles, all right, that's your Greek letter theta. If this is your point of view, it's like you're standing here. That means this side is the opposite. And so this one has to be the adjacent. But look, if I make the angle theta down here, now this is opposite and this is adjacent. So do you see how it does make a difference? You have to pay attention to where your angle is. So we're going to find x for each of these. All right. So you have to pretend that you're standing right here. This is your point of view because it's the angle that's labeled. Okay. So that means 11 is what? The hypotenuse, the adjacent, or the opposite? What is this that we have? Good. That's adjacent. And what's x? Hypotenuse. Do we want sine, cosine, or tangent? If we have adjacent and hypotenuse, sine, cosine, or tangent? Good, cosine. It will be cosine of 37 degrees equals 11 over x. Now, before we type it in the calculator, mathematically, here's what happens. And I want you to get to the point where you don't have to write this out every single time, but mathematically, here's what's going to happen. You would multiply over the x. So you would have x times cosine of blah, blah, blah equals 11. And then to get x alone, you would divide by the cosine of 37 degrees. So what you're going to type in your calculator is 11 divided by cosine of 37. But my hope is, and watch me point to this, we'll all type it in together, is when you see this, you'll just go, oh, I'm going to type 11 divided by cosine of 37. I don't want you to have to write that every single time. All right, but let's go ahead and type that in. How do I get the fraction bar? It's alpha y equals, and we want 11 over cosine 37. Cosine's kind of like right in the middle. It's above the 8, like above the parentheses. Did y'all find it okay? Anyone feeling brave? What'd you get? Okay. Again, I want 3 decimal points. I don't know what Delta Math is going to say. They probably say the 10th. That would be 1 decimal place. I want 3. Okay. So X is 13.773. Try it again. You have to pretend you're standing here. This is your point of view. That means, oh, bless you, X is the what? Opposite, good. 13 is adjacent. Do we want sine, cosine, or tangent? Tangent. Tangent of 32 degrees equals X over 13. Now, mathematically, and again, I don't want you to have to write this out every time. I'm showing it to you now, but I hope you get to a point where you don't have to write this. Mathematically, here's what's happening is that the 13 is getting multiplied over. So what you want to type in your calculator is 13 times tangent of 32. And you don't even have to hit times. If you just put 13 tangent of 32, it's going to work. I got 8.123. Okay, thank you. I like when you guys confirm me, because again, like I'm human, and if I hit one button wrong, it's going to be wrong. So I need confirmation. All right, pretend you're standing right here. That means X is the what? Opposite, good. And that means 5 is the adjacent. So do we want sine, cosine, or tangent? Tangent. Tangent of 50.1 degrees equals what over what? Good. How will we type that? Good, you're multiplying the 5 over, so it'll be 5 tangent of 50.1. I got 5.979. This is a situation where truncating is really great, isn't it? Because then you don't have to worry about like what happens to the 9 and then the other 9 and how it cascades. So yeah, 5.979. All right, here's your point of view. You have to pretend you're standing here. That means X is the what? Oh, wait, hold on. That says 60 degrees. What does that mean this angle is? Oh, you know what? This is a 30, 60, 90 triangle. So we don't even have to do trig if we don't want to. We can use what we did on the other side of the paper. This is the hypotenuse. To get from the hypotenuse to the small side, you're just going to divide by 2. So 11 divided by 2 would just be 5.5. So if you notice something like that, that can help you out. Now, there wasn't one written on here like this, but hold on. I'm going to do a question 13. You're all going to be fine, okay? In fact, I'll let you guys help me make it up. Draw a right triangle. We'll put X right here. Give me some numbers. 7. What else do we want? I need a number bigger than 7 this time. 12. Notice where I put the variable. It's the angle. Okay, so I kind of flipped it around. Across from that, 7 is the opposite. 12 is the hypotenuse. So do we want sine, cosine, or tangent? Opposite and hypotenuse. Sine. It is sine of X equals what over what? 7 over 12. Good. The way you have to type this is, because you want the angle, you have to anti-sine. It's sine inverse. Do you see on the sine button how above it, it has sine as a little -1, how -1 means inverse? How do you get that on your calculator? Good. So hit second sine, 7 divided by 12. So if you want the angle, you have to inverse trig. So sine inverse, cosine inverse, tangent inverse. And so what you end up with is the angle. So it's 35.685 degrees.